Right. Good evening, everyone. So, for some time now, we, as Africans, have been utilizing Earth observation data to develop services, to train and to learn about our changing environment. And the reason behind this is the fact that our growth and existence is largely dependent on that. I mean, as humans, we need to eat, reproduce, and so forth, and we need food. We need to manage our environment and to ensure that it's pristine for growth. So over the years, the African Union has seen the need to build capacity and to develop infrastructure that will allow Africans to exploit Earth observation data. This is very evident in the Science, Technology, and Innovation Strategy for Africa that is implementing the Agenda 2063. On your right, you can see a tall list of projects, initiatives, programs, and so forth that has helped Africans to exploit Earth observation data. That and all those initiatives you see there is very, very, very dependent on having infrastructure that allows us to use data. So in this presentation, I am going to talk to you about what we need to start looking at, especially moving into GMES Phase 2, so we will be able to utilize existing infrastructure, build capacity that will allow us to use data properly. On this slide, I'm trying to point you to the fact that there are some milestones when it comes to building the expertise and physical infrastructure to send spacecrafts into space. You realize that there are about 13 milestones. But you can see that Africans are a bit behind. For instance, countries like Egypt, Nigeria, Algeria, I know South Africa are doing so much to send low Earth orbiting satellite into space. It is important we build on these expertise, help other countries to send satellite into space that will allow us to be looking at the key processes that drive our environment, our forest change, our fish distribution, and so forth. Because we don't have much time, I'm not going to spend too much time on a lot of the slides. But one of the take-home message I want to send across here is the fact that we need to climb up that space technology ladder. If you look at the 13 list of milestones, most African countries may possibly haven't even got into the third or fourth milestones. There are about more than 50 African countries, and we need to start looking at ways where we can send satellite into space, either for remote sensing, either for telecommunication and so forth, so we can protect the resources we have. Apart from Egypt, Algeria and so forth, other countries are doing a lot more. But as we move through this session, some of the questions that we need to ask ourselves is, what priorities and technical investments do we need to make so that we can build this expertise and the infrastructure to exploit Earth observation data? Do we make or buy satellites? Do we invest in telecommunication or remote sensing satellites? Do we build payloads instead of building sensors that can help us sense our environment? Do we train more engineers and so forth? These are critical questions that we need to have answers to as we move into the new era. Again, we know that internet access is a challenge in in Africa. But thanks to UMetcast, GeoNetcast, and those technologies, we are able to exploit Earth observation data. But one of the things we must start thinking about is the fact that we need to talk to companies that own huge fiber optic cables that lie beneath the ocean on how they can also support Earth observation technology. I know these companies have a lot of corporate social responsibilities, and they will be more than happy to start helping African institutions to have access easily over the internet. These are some of the things we should start thinking about. Again, I know most universities around the world have a network of internet connections. What it means is that a university in Ghana will collaborate with a university in Nigeria, and they, at some point, would have some nodes where they can exchange data, library information, and so forth. It's also another avenue that we can start thinking about that will allow universities, private sector institutions to start thinking about ways of sharing information so that we can improve on our service delivery. There is a good example in my country. It's called Garnet. So there are about 10 public universities are looking into building that huge network that will improve communication between universities. We have to start looking at those examples. One key thing that we have also realized we need to start looking into is our ability to collect in situ measurements. So most remote sensing scientists know this. For us to get accurate measurements from satellite, we need to collect proper field measurements. More often than not, there is sparse data in Africa, but there are opportunities that we can look at. There is Internet of Things and low-cost sensors. So one of the gentlemen from Ghana indicated the fact that he had worked on using cheaper tools to measure his environment. That is the point I'm trying to talk about. You can buy sensors, you can buy batteries, you can buy temperature, humidity sensors, and so forth. You can build this network around coastal areas, within forest areas, on the desert, measure atmospheric processes, and compare this with satellite. That will help us improve satellite measurements and build better algorithms to develop models for managing resources. So these are things we can also start looking at. Another key thing that exists but we are not looking into that much is cloud computing and high-performance computing. These tools can also help us to use that huge volume of data that sit in silos around the world. Having access to those data sets, again, would allow students to have data easily, would allow novices to go out there, process data. The way these infrastructures are built is that all the high-level computing that you would have done, it's done for you on a click of a button. Sometimes you get time series analysis, you're able to visualize your data and so forth. There is a good example called Google Earth Engine. A lot of my colleagues here know about it. There are already packages, there are already scripts written out there, and you don't have to be an expert. All you do is you pull 1, 2, 3, 4 modules, you put them together, and you have a functional script that can help you generate an interesting plot. So these are things we should also start thinking about. Already, UMETSAT, the European Union, ESA, and so forth are collaborating to build these tools. They already have processing chains. There's data already sitting on Wikio. You are able to process and easily share your outputs with users. So we should also start thinking about these tools. An example of cloud computing is Wikio that you see here. So over here, you are able to visualize global scale products. You are able to do your analysis, pull different types of data on the cloud, and process to generate information. And this is what we need for resource management. And it's important we start thinking about these things. So one thing that I feel we don't have any reason not to look into, is helping young students to build expertise, especially in programming. All the things that I have indicated earlier, most of them it requires a lot of money to do that. But learning to code and to process data from your computer is doable. Where you are unable to have that resource to build a huge infrastructure for processing your data, a simple GPU, graphical processing unit, that sits on your laptop or on your desktop can help you with multi-threading, multi-processing, using packages like Dask in Python. You can process large volumes of data. So having skills in programming will be very, very useful. And to be able to do this, we need to have clinics, we need to have competitions, hackathons, and so forth. That will bring people together, create that environment for them to work. I have shown here some of our activities at the University of Ghana. You can see a colleague from Kurat assisting us in supporting young girls. Out there, we are a bit gender sensitive. We want to also encourage a lot of women to get into Earth observation science. So we need to pay attention to that. These things are so important in building that critical mass. Earlier speakers indicated that for us to step out of the situation we find ourselves in, we need to have that large critical mass that can allow us to move forward. And women are very important in this. So I will make it very snappy in all my talk now. The point I want to make is the fact that EO programs can be very successful if we have access to data. We need to encourage private partners, and we need to build businesses around this sector. That is one way that we can make some money for our countries and for the continent. It is also important we also collaborate with the institutions out there so that we can share knowledge, build capacity, so that the next generation of scientists will be so proud of us. Again, as we have a lot of policymakers among us, and it's important we provide them with that needed information that can help them plan and govern our countries very well. So that is the end of my story, and thank you very much.